Check, 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 check. Hey guys. Let's try that again. Check, check, check. Hey guys. Hey. All right. Everybody enjoying some pizza and beer, soda, etc. All right. Awesome. Cool. All right. We're gonna go through a couple announcements, and then we're gonna get Dave up here. So this is Google Proximity Beacons with Dave Smith. This is our November meeting. So 6 to 6:30. You guys did it. Congratulations. You networked. Hopefully you talked about people looking for work. Is anybody here hiring? Anybody want to make a quick announcement that they're hiring? Yeah. Two senior level DBAs and a customer support rep with accounting experience to work at Zero. See Michael, is that correct? See Michael later if you're interested in that. If you want to be a speaker here at GDG, we'd love to have you. Check out our cool, awesome new space that you can speak in. For those of you who are curious, the old space is, we're still in that space as well. We just expanded over to here. We are, yeah, good point. Talk to me and give me your resume because we get referral bonuses. We're currently hiring 15 different positions, everything from Android, iOS, mobile web, QA, some executive level positions, etc. So come chat with us. 6:30 to 7:30, Dave will talk, and then I'm gonna kick you guys out of here as quick as possible. We're gonna raffle off some Google Cloud credits at the end, and that'll be that. So quick announcements. Let's see if I can click on this and show you guys this cool thing. Apparently not. Let's not worry about it. So we did a really cool, crap, how do I don't know, this recording is freaking me out. Can we edit this later? Oh, here we go. Here are the pictures. So we did this really cool event up at Google Boulder. So I'm sharing this so you guys can be a part of it. Next year, I can see at least 2 people who are part of it here, 3, 4, at least 4 people. That's a pretty good percentage. So it was awesome. We had Sphero, we had SparkFun, or who are these guys? What are they called? SparkFun? Is that right? SparkFun, the Boulder company, awesome. We had Notion right here, doing some awesome Minecraft stuff. So anyways, there were about 100 people, kids, family folks, and there were GDG members who acted as mentors and helped kids learn how to code and do cool technology stuff. So definitely, we'll do that again next fall, I'm pretty sure. The year before, we did a hackathon on Android Wear, and we found this to be just super, super awesome and fun, bringing the kids in and doing all this cool stuff. All right, so how do I get back? I don't know why it doesn't want to present anymore. Anybody know how I change into, oh, there we go. Awesome. Okay, so next month we have a Google testing talk, which is going to be really interesting, and we're going to take a vote right now. Would you rather have it here, raise your hand, and the other choice is going to be back across the street. So we'll start with across the street. How many people want to have it across the street? And you have to vote. So just across the street, all right, great. And how many people here? Excellent. All right, so it'll definitely be here. We traditionally have GDG meetings on Tuesdays. They're not any specific Tuesday of the month. So the first choice is Tuesday, December 15th. The second choice is Thursday, December 10th, which gets a little closer to Christmas, which is a little dodgy. So we'll take a vote here, and this is an optional vote. So all hands for Tuesday, December 15th, which is actually the closer one to Christmas, sorry. And how many votes for Thursday, December 10th? Tuesday wins. All right, so Tuesday here. And this, geez, what disaster. I don't know what that bottom, oh, we'll get to the bottom one in a second. Oh, this is what it was. We have an event in January already scheduled. It's gonna be at the Commons on Champa. Has anybody been to the Commons on Champa yet? Okay, a couple people. It's a really cool space. It's walking distance from here, but you know, like probably a 10-minute walk. It's by the Performing Arts Center. And it's a place that Denver City started to promote entrepreneurial stuff. And they're being really cool and letting us have the space for free for that night, this one time. So we're going to check that space out. And we got a great Denver Startup Week speaker doing an AdWords presentation. And this is the December event, which needs a date and needs a location, but we now have a location and a date. So I'll update that tonight. This was the picture we showed at our last meeting. This is the space you're in right now. So we still have the old office. This was the new office, and it's looking a lot better than it did in this picture. AndevCon is coming up. Are you at AndevCon? No, I didn't think so. Okay, so in December in Santa Clara, California, if you want a discount, you can get $200 off with my last name as a discount code. And GDG members Kelly Schuster and myself for speaking there. And I do want to thank our sponsors. We're still sponsored by WebRoot. You can get a free license of WebRoot. If this is going too quick, just ask me later. It's like they're a huge company up in Broomfield that provide real-time protection against new threats, it looks like. So you can get a free license there. And iTriage, super awesome. Pizza, beer, space, they're great. And that's it for the announcements. And we'll switch over to Dave.
Yeah. Okay. Hi, everybody. Pretty good. My name is Dave Smith. I work for New Circle, it's a company based out of San Francisco. I am here in Denver, though. New Circle is a training organization, and I'm responsible for the Android content there. So if any of you are interested in getting better at what you do and you want to talk to me about public or private training, specifically, I mentioned the bit on testing. We are doing a series of Android testing classes. The next public class will be at our San Francisco office in January. So if you are interested in unit testing and the Android testing support library and all that stuff, and you want to learn more about that, come talk to me and I can get you acquainted with some of that information. But that's not why we're here today. Today, I am here to talk to you guys about beacons. And more specifically, we're going to talk about Google's beacon APIs and some of the features and functionality that they've provided to sort of enhance beacon applications. Just quick show of hands, how many of you have played around with some kind of beacon before? Okay, about half of you or so. So just shout out a couple of things. When you think of beacons, what comes to your mind? Physical web, okay. Sorry? Can't hear you. Clear text, okay. Okay. Bluetooth? Proximity, okay. So in your mind, how would you define a beacon? What is a beacon? Go ahead. Okay. Okay. Anybody else? Okay, those are all pretty good descriptions there. The way that I would characterize a beacon, at least for the purposes of this discussion here, is a beacon is a device that is typically Bluetooth enabled. It doesn't have to be, but everything we're going to be talking about here uses Bluetooth, specifically Bluetooth Low Energy. Beacons are devices that advertise something. Doesn't necessarily matter what that thing is, and in fact, different beacons advertise different things. But all beacons are advertising some piece of information out to the world all the time, okay? And those are devices that, other than what they're shouting out and broadcasting, you really have no ability to interact with them or connect to them or anything like that. They're basically a giant mouth with no ears. Okay, and again, typically they're going to be using Bluetooth Low Energy. Now, that's important for a couple reasons. The first is that Bluetooth Low Energy is, by definition, because it's supposed to be low power, very low bandwidth, which means that specifically in the case of beacons, the amount of data that these beacons can transmit is very small. It's essentially 31 bytes at a time. And as I mentioned, typically a beacon is only going to advertise one type of thing. Now, there are some special cases we'll talk about where they may interleave between one or two different things. But generally speaking, you've got 31 bytes of data to represent what that beacon is supposed to say to the world. That's not a lot. Okay? And that characterizes some of the things that we're going to talk about today and why these things exist in the first place. Okay? So I'm going to talk to you about two specific elements today. I'm going to talk about Google's Proximity Beacon API, and then we're going to talk a little bit about the Nearby Messages API. Has anybody heard of either of those things before? You've just heard of them. Okay, a couple folks. So it's going to be a little bit mostly new, so that's good. So we'll jump right in. The first piece that I want to describe to you is the Proximity Beacon API. This is a back-end service that is provided by Google for free, as long as you have a Google account and you can get into the Google Developer Console and all of those pieces there. This is a back-end API that is provided to you by Google as an assistance to allow you to better manage and more easily deploy your beacon fleets into the field. Okay? This is not hardware. This is not even necessarily client-side software. This is all a web service. Okay? And it's a back-end web service that exists only for the purposes of allowing you to address the issues associated with managing tons and tons of beacons out in the world, right? You think of most beacon applications, these are typically these little single devices like the one I have in my hand here. In some cases, you could turn your mobile device into a beacon or maybe even a desktop, but a lot of times beacons look kind of like this. Right, so, and we could have hundreds or thousands of these out associated with whatever our application is. Maybe it's an indoor location-based application or an application where beacons denote individual retail stores in a distribution or whatever the case may be. You could have tons of these things out representing whatever your application is. And on its face, this little thing doesn't help you a whole lot. And even the beacon manufacturers don't necessarily provide you with a whole lot of services to make the deployment and the managing of that deployment easier. That's where the Proximity Beacon API comes in. Most people who have done large-scale beacon deployments of some kind have had to write most of this themselves before Google came along. So the idea is they're giving you something that you probably would have otherwise written yourself, but now it's going to be given to you for free so you can use it using Google's backend. So the Proximity Beacon API provides really three primary pieces of functionality to you to help you deploy and manage your fleet. It helps you provision beacons, which is probably the most common thing that most people would have to write themselves for large-scale deployments. It also helps you with diagnostics, which is a less common use case, but still extremely helpful. And in my opinion, probably the most interesting one is they allow you to attach additional metadata to a beacon. Okay. Now again, I mentioned that these beacons don't have a lot to say and they don't have a lot of space to say it in. So in order to make beacons a little bit more useful, Google has come up with a way to try and allow you to provide additional data, additional context associated with this tiny little device. Okay. So let's talk about that piece first. So one of the nice things about the Beacon API is Google does not lock you into a particular beacon type. Those of you who are familiar with beacons, you're probably familiar with the fact that Google has their own beacon format called the Eddystone format. But that's not the only one out there. Apple has iBeacon, and those are probably the two most popular. But there's also a fairly popular standard called the Alt Beacon, which was developed by Radius Networks, which is a company that manufactures beacons just like the one I have in my hand. Okay? So all of these standards have existed for a fairly long time. Eddystone's only been around for a few months, but the others for several years. Okay? And Google is not locking you into their format. Just because you want to use Google's API doesn't mean you're going to need to buy Google beacons. You can, if you already have iBeacons in the field, you're already using alt beacons or something else along those lines, those will work with this API. All of those are supported. Okay. Now, if you don't already have beacons deployed and you're sort of starting fresh, I would recommend to you that the one you choose is Eddystone. And as we go through this, I'll kind of give you a couple reasons as to why that is. I'm not going to talk too specifically about those formats. I'll give you some links to resources at the end where you can learn more about the individual beacons themselves. I've got videos from talks I've given previously about that specific case. We're going to talk more about the APIs here today. So as I mentioned, what I think is probably one of the most interesting use cases of the Beacon API is this ability to attach additional metadata to a beacon. Okay, so walk through the typical use case for just a minute here. This beacon is sitting somewhere out in the world. Could be on a bus stop, could be here in this room, maybe on the soda machine, who knows, rack of clothing even. And this device is just advertising an identifier. It's a unique identifier. The actual makeup of that depends on the beacon format, but as I said, you can only put about 31 bytes in here. So they're typically 128-bit unique identifiers of some kind. Okay, it's just a number. And it's just spewing that out into the world, and every single beacon that you own is spewing out a different number. So if you want to use that information in a client application running on a mobile device, then you have a couple options. The most common is your mobile device is going to be scanning for these packets that are being advertised out in the world as the user's walking around whatever that physical space is. And it's able to pick up what those identifiers are. And in a simple application, you might be able to just hard code all those identifiers into your app. I'm not sure I would recommend that, but you could do it. Right? So in the simplest case, you could say this beacon, which is identifier 12, is the front door. And identifier 15 is the back door, and so on and so forth. You could upload that information to a server somewhere and identify that at any given time, this beacon identifier 12 is the front door, but at maybe some point later, you want to reconfigure the server. And at that point, this application has to be able to read that identifier, upload it to the server, and figure out based on that what that beacon actually represents. Okay, that's a more common use case, and that's essentially what we're given with the Proximity Beacon API. But what they give us is a very flexible model into which we can put that information. Okay, so the Beacon API has two primary data structures that really make up the majority of what we're doing here. The first is the beacon data structure, right? And a beacon is comprised of an advertised ID, a location, stability, some properties, and actually a description is another I didn't put in there as well. The advertised ID is the property that represents the number coming off of this thing. Okay, so every single one of these beacons is tied to this advertised ID to tie it to a specific piece of hardware sitting on something in the real world. And that advertised ID has that actual numeric value, whatever it is, and the beacon type, whether it's Eddystone, iBeacon, or AltBeacon. Okay, so that's sort of the key representing that information to tie it back to the physical world. But then we've got all these other elements in here. We can apply a beacon's location, and that can take a number of different forms. It could be just a lat long value of the address or wherever this particular beacon is installed. If you're doing indoor location of any kind, they have a property for level. So is it on the ground floor? Is it on the top floor? So you can do some more indoor location mapping based on that information. And if you're familiar with or are using the Google Places API, you can attach a Places ID to a particular beacon as well. So we're not going to go into the Places API specifically, but it's an optional feature that if you're already doing that to map out and bring in client-side to your application all these different locations that you may have, you can tie those to beacons very quickly by just attaching that Places ID to the beacon in the backend API. Okay. Stability value is associated with how mobile is this thing? Should it be static? Is it on a car or something that is constantly moving, or is it somewhere in between? And you'll see, this is an optional value as well, but you'll see when we get to diagnostics how there are some interesting things that the Beacon API can do based on that information. Okay. So knowing where a beacon should be by its lat long value and whether or not it should always be there, like with a stability value of fixed, allows us to do some interesting monitoring a little bit later on. Okay. So you have the stability value, and then this idea of properties. Properties is just key value data. You can attach whatever the heck you want to this beacon. It's just sort of basic keys and values. So it could be contextual information that's specific to your application. What room are you in? We already have what floor. Maybe what's the address of where you are, or anything else that's specific to your application that you want to associate with that beacon. Properties are the simplest way to do that because it's just key value data. Okay? So those things make up that beacon data structure. And one of the important things to remember, one of the great things about this API is that the beacon, while it has an advertised ID associated with it, the two are not the same thing. And the important thing there is that we're sort of divorcing the idea of this piece of hardware from what it represents. So we have this advertised ID being the thing that's stuck on the physical element, but the rest of the content declares what this thing actually is. And why that's good is what happens when this thing blows up. Maybe somebody gets it a little too hot, lets the smoke out of the chip, and it's not coming back, right? So we have to go out and we have to replace a new beacon on that same element. By divorcing the beacon's role from the advertised ID, you can use the API to essentially say, okay, this ID is now associated with this beacon. Okay? It's not quite as straightforward as all that, but the API gives you the steps to be able to do that. So you can accomplish that by saying, this is what the beacon should be, this is its role, and this is the piece of hardware currently there advertising that content. Okay? And they can be married together or divorced apart. The other piece is an attachment. And this is going to be a little bit more interesting for what we're talking later on. This is just a blob of data. Be whatever you want it to be. It's defined by just a name, type, and this blob. And this blob, when you actually upload it, is just a Space64 encoded blob of whatever. It could be binary data, it could be textual data, it could be whatever you want. It could be an image. The only thing about this, and they don't explicitly declare this in the documentation, but through conversations and some of Google's videos, the basic idea here is that attachments probably should not exceed about 1K. So it's not a ton of data, but it sure beats 31 bytes. Okay? An attachment is then associated with a particular beacon. Beacons can have as many attachments as you would like to include. So a single beacon can be associated with 1 attachment, 2 attachments, 10, 100, whatever. Okay? Whatever suits your application. The idea being that when a beacon is observed in the field, this API gives you the availability to tell the API which beacon you observed and have it return back to you, well, here's all the attachments associated with that beacon. Here's some data you can actually use. And if this beacon tomorrow changes to be a different radio with a different ID, fine. The client side is going to get the same data because it's looking at the attachments. It's looking at the metadata, not the actual hardware element itself. Okay? So attachments are going to be really interesting because that's the piece of data that's going to map directly to the client side when we talk about nearby a little bit later on. Okay? So attachments are pretty cool. In addition to attaching this additional data, the Beacon API also provides provisioning functionality. So at some point, you have to be able to tell Google about this beacon. So you have to register it with the API. And at some point, as I mentioned, you may get to the point where this hardware is no longer usable. The radio doesn't work, or it broke, car ran over it, something like that. And this beacon can't be in service anymore. And at that point, you would need to decommission it. So registration and decommissioning are one-time operations where you bring it into service, and then when it's no longer usable, you take it away. That's important to realize because you can't bring something back from being decommissioned. So just because you don't need it doesn't mean you want to decommission it, because you won't be able to use it again. That ID is used forever, it's gone forever, and it can't be resurrected. The Proximity Beacon API keeps track of every advertised ID, and they all have to be unique. So this beacon ID is currently registered to my application that I'm going to show you as a demo. If you were to try and take this beacon ID and register it with your application, it would not work, because this instance already exists in the whole of the Proximity Beacon API. Okay? So that's why it's important not to decommission things that you may actually need, because you're not going to be able to get it back. If you want to take beacons or the thing that the beacon is attached to into or out of service, you can use the activate and deactivate functionality to do that. So when a beacon is registered, it's registered into the active state. This is a beacon that should be observable in the world. When you query for it, it should get returned, all that stuff. But if, let's say you put the beacon on a service truck and that truck is in for maintenance or something like that, you could deactivate the beacon temporarily while it was out of service. And then when it goes back out into the world, you can reactivate it again. So that functionality allows you to go back and forth as needed, as opposed to decommission, which is a one-shot operation. Okay? So all this functionality is provided to you simply so that you can bring these pieces of hardware into a system where you can manage them. Okay? And as I mentioned, this is the sort of thing that most beacon implementers have written themselves at least once. Okay? So this is the piece that you probably will need, regardless of whether you use the other features and functionality or not, for some large-scale deployment. Okay? All right. And then the last piece of the API is diagnostics. Diagnostics. This part of the API still has its training pants on. So the Proximity Beacon API technically is still in beta. If you look at the documentation, their current version is beta 1, and they are iterating on this to make it, change it and make it better. So everything I'm telling you, at least in terms of the actual endpoints and function calls, could potentially change in the future. Diagnostics is one of those cases where we know what it's going to do, it just doesn't do any of that stuff yet. So some of the stuff I'm going to tell you might be interesting to you, but if you run out and try and do this tomorrow, most of it's not going to work. Okay? But it's interesting to know what's going to be available to you and potentially where they might take it from there. So the diagnostics functionality allows beacons that are able to report telemetry metrics from the device. So those are metrics like battery level, temperature, how long has the thing been up since it was reset the last time, basic information like that. All of that information can be brought up when these beacons are observed into the API. And the backend API on the diagnostics side is meant to allow you to generate reports off that information and get alerts from that information. So things like battery level would be interesting to know how long is it supposed to be before the battery in this beacon dies, if it's battery powered. Am I going to have to go out and replace the battery in it before it stops transmitting and the users can't actually interact with that thing? So part of the diagnostic API is to analyze battery values as they come in and then determine from that information what is the estimated time left before the battery is going to die. And the diagnostics will report that back to you so that at any given time you could look at a report and say, oh, we've got 3 or 4 batteries that need to go out and be replaced in the field. Okay? That's the only metric that they let you read right now. Hopefully you'll see alerts like that on some of those other values I mentioned, but right now it's just battery. The other alert that's currently in there has to do with location. So as part of the observation of beacons and the uploading of that data back to the Proximity Beacon API, beacons that have a location and are intended to stay at that location can be analyzed by the Proximity Beacon API. So as part of the Beacon API, when a mobile device like this observes a beacon and uploads that information up to the server, it will not only tell it what beacon it found, it will tell the server where it is right now. So here's my location when I observe this beacon. And if that doesn't match the location where that beacon is supposed to be, and that beacon is supposed to not move, then that will also generate an alert that you can view using the Diagnostics API. So you can get some idea of, well, was this thing stolen? And if so, maybe where it was or something like that. You can get some information around this thing, we know where it is, but it's not where it's supposed to be. So that information you can get from here as well. Now, interesting point about diagnostics. All of the data necessary to make diagnostics work only come off of the Eddystone format. Eddystone beacons are the only beacons that support this telemetry data in a packet frame that is advertised off of this device. So all the beacons that I have around the room are Eddystone beacons. So in addition to advertising this identifier I've been talking about, they're also advertising in between each of those packets, current battery level, current temperature, and all that stuff. That packet format doesn't exist in the other beacons, iBeacons and alt beacons. So if you're using those beacons in this deployment, the entire diagnostics API will give you nothing. Okay? So this is one of the reasons why, if you have a choice, Eddystone is probably a good choice, okay? Because you'll get some of these additional features for free. All right, so that's the server side. We've got all this functionality provided by Google that allows us to provision beacons, as well as attach all this awesome metadata to it so that our beacons can actually be more useful than just these tiny little numbers that we have to try and decipher on the client side. Okay, we can now push that back to a server and simplify the client-side software significantly. Is there a question? Absolutely. So the question was, do beacon IDs have to be unique? And if so, what would stop someone from basically jumping in ahead of the curve? The answer is nothing. I mean, the way that these beacon identifiers are constructed depends a little bit on the format. But at the end of the day, every single format has at least all or part of it dedicated to a unique identifier that is specific to an application. So Target or Kmart or whomever should have a single identifier for their application that they're using. And then the remainder of that ID is unique to the individual instance, right? So it's very much the case that if you want, specifically with the proximity beacon API, if you want to use this API, it would be best to register, you know, basically everything that fits into your application's namespace, if you will. Because you're right, if someone else beats you to it, you can't use that beacon ID anymore. You would have to basically choose a different ID for the piece of hardware that's already been used and go off that instead. There's another question? No, actually, so the question was, do they come from Google? These numbers are, they're really defined by you. So depending on where you get your hardware from, most beacon manufacturers will burn in a unique ID for you. But the traditional beacon formats, primarily iBeacon and Eddystone, defined the standard in such a way that they tell you how to make up your own. And ideally, even though the manufacturers make one up for you, you should make up your own and program it into the beacon. So it's not like I can go register my ID with Google so no one else goes and gets it. The idea is they're designed to be unique such that mine won't collide with yours unless we intentionally did that for some reason. Yes? Could I intentionally change the hardware to collide with someone else's? So I see what your beacon state is, and I change mine to that, you know, so I can say something clever instead of what you wanted to say? Sure. So I think the question is basically, could you intercept another beacon's transmission by duplicating it in some way? Could I just have it pretend? Sure. The short answer is yes, but at least if they're within the same proximity, you can't somehow cause your signal to override theirs. So yes, I could. I mean, it's very straightforward to walk around. I can download any app from the Play Store that scans Bluetooth, and I can pick up exactly what the advertised IDs are of all these different devices as I'm walking around. So I could figure that out, program it into my beacon, and have it transmit the exact same information. However, that doesn't stop that device from continuing to transmit. So while I could take what they're doing and maybe modify it a little bit, now a client who's in proximity of these beacons is seeing two transmissions instead of one. And ideally, if you're able to guess what another ID might be, then you might be able to fake it out a little bit. But all these identifiers don't really have any identifiable information in them from an application perspective. They're just numbers. So at best, you could broadcast the same number as the one you were stealing from, or pick up another number and hope that that was used by something else and try and confuse the application. So on the client side, you might be able to defend against that just by having some understanding of where these beacons should be. So that if something like that happens, you say, well, I got this identifier, but that beacon is way out of left field. Then say, okay, that's probably not real, or something like that. Sure, yeah. You should never have more than one in close proximity or whatever your application rules are. But yeah, there's nothing precluding someone from understanding what the beacon is advertising and duplicating it, or trying to modify it. The question is, what does the client application do if that happens? And that's up to the developer. Okay, so let's move now to talking about the client side. So we've got these beacons, they're out in the world, and we've registered all this cool information with the Proximity Beacon API so that all these beacons are more than just a number. Now they've got all this cool metadata associated with it. How do we see that information in the application on the mobile device, in this case, in the Android device? This is where nearby messages comes in. Now, truth be told, you could do everything I'm about to tell you with the Proximity Beacon API directly. I could use API calls just like I would for the provisioning and management to declare to the API, here's a beacon that I observed, give me all the attachments and all the additional data. That functionality exists in the API. I wouldn't necessarily recommend doing it just because it's a lot of steps. There's no client-side library for this or anything like that, so you'd be writing all those codes with raw REST HTTP type stuff. Okay, not impossible, but not everybody's favorite thing to spend their time doing either. Okay, nearby messages allows you to simplify that greatly on the client side. Okay, now nearby messages specifically actually covers a larger range. It's a Google Play Services API that is responsible for allowing two devices that are in close proximity to transfer messages back and forth and quickly communicate. So maybe two Android devices or an Android device and an iOS device. If they're in close proximity, you can publish a message to another device. Okay, that's the core of what this API is supposed to do. But what they've done is they've brought beacons underneath that and allows a beacon to be a type of device publishing a message, and then you can use the same API to just accept those messages as if it were coming from another Android device or something like that. So it's just a subset of the larger nearby messages, just happens to be the piece we're going to be focusing on here. So the use case here is your mobile device at some point is going to come into proximity of one of these beacons. Okay? Probably this is happening over Bluetooth, at least in what we're discussing here. And so the mobile device is going to recognize that it sees this beacon. It's scanning for this signal, it sees the advertisement, and it can pull out that unique ID. I got the number, great. Now what? What Nearby Messages does for you under the hood is when that beacon is detected, it will upload it to the Proximity Beacon API and say, I've observed a beacon, as well as all that additional metadata like the current location and other things that make that API truly useful. Things that are optional, but if you don't do it all, it doesn't necessarily work to your advantage. Okay, so Nearby Messages does all the work of communicating with the API, declaring that I've observed this beacon. Okay. Then the beacon will return, the API will return back to the device the attachments, just like I described to you before. What is a little bit different with Nearby Messages is that they actually transform the data a little bit. On the client side, you don't see attachments, you see messages. But a message and an attachment are essentially the same thing. Okay, and I'll show you in just a minute how the data maps across. But effectively what happens is automatically, all you have to do in your client-side application is declare that you want to use Nearby Messages and declare when you want to be listening for those messages. And then anytime your device walks past a beacon that is registered to you, you'll just see those attachments come in. All the other steps and moving parts underneath the hood. Okay, so it simplifies your code a ton. Yes? Good question. So the connection to the cloud, what radio is that using? That's a network connection. So cell radio, if it's active, Wi-Fi, whatever, it's going to the remote server. Good question. Okay. So before I get there, the other nice thing about Nearby Messages is that it's cross-platform, right? A predominance of APIs that are in Google Play Services are supported on both iOS and Android, and Nearby Messages is no exception. So by using the Proximity Beacon API and the Nearby Messages APIs, you can build out your beacon deployment and not have to worry about it being Android specific or only working on iOS. It will work on both platforms using the Google libraries, even though they're produced by Google. Okay, so don't just think that because it's Google, it's only going to work on Android. Play Services works on both, and Nearby Messages works on both. Okay. Now, having said that, Eddystone happens to be one of the only formats that works seamlessly across both platforms. This is a little bit ironic, but iBeacon doesn't work well on Apple. It turns out that because of the way they built the iBeacon APIs, iBeacon devices don't show up through the Bluetooth APIs, they show up through the location APIs. And when you try to put Play services on top of that, it's not able to pick up iBeacons the same way it can other types of beacons, because Apple is treating them special, and it turns out that screws up iBeacon's ability to work well through nearby messages. Only on iOS. iBeacons work great on Android using nearby messages. Sit on that one for a while. So again, if you have a choice, Eddystone is a better choice, because especially in the cross-platform case, if you're using this on the client side, this is going to work perfectly seamlessly with this whole mechanism on both platforms. Okay? All right. So how does it fit everything together? Well, I'll show you an example here in just a minute, but the basic idea here is that you're going to have a Google Developer Console project set up that these APIs are going to attach to. And there's two APIs that you need to enable. The first is the Beacon API, and the second is the Nearby Messages API. Both of these APIs have to be enabled on the same project. And that allows Google to know when you are communicating from the client side using Nearby Messages, which beacons are yours. And they do that because those are married together in the same project. Okay, so that always has to be the case. And that way, the client side can use Nearby. On your server side, you're using the Beacon API, and under the hood, they know that the two are the same. Okay, so your beacons have to be registered against an API using API credentials that are in the same project as the API credentials you're using on the Nearby side. And I'll show you that as an example in just a minute that might make that a little bit more clear if it's fuzzy at the moment. The other thing, as I mentioned, that Nearby does is it transforms the data. So that name, type, and data that are in the actual attachment when you're working with the API, on the client side, they get transformed into a type and content on a message. Other than the name changing, exactly the same data. Okay? So you're not going to see an attachment anywhere in the Android code or in the iOS code. They're going to be called messages. But the data is from the attachments that you originally created when you provision these things in the API. Okay, so a little bit of the semantics, but everything's still the same. Okay. Nearby Messages is an API, actually Nearby in general, is an API that requires user permission. Now, this is not quite the same thing if you are Android developers. This is not the same thing as runtime permissions in 6.0 versus the old permissions model. This is done by Play services, and it's going to happen on any version of Android. Okay, this is an API that, because in the general case, it can use any number of radios to do its job, it could be fairly power inefficient. So they don't allow you to invoke the API unless the user has granted you permission to do so. So there is an explicit dialog shown by Play services that the user has to agree to before you can invoke any of the Nearby APIs on your device. Okay? It's a fairly simple thing to do. You just call request permission, and it either says, yes, you already have it, or we're going to show the dialog and we'll tell you the result later. You know, same as any other permissions request, but this has to happen ahead of time or it will fail anytime you try to access any of the APIs. Okay, so the user has to grant permission first. After that, the code involved in actually subscribing to that API is a ton. Right? What is that, 4 lines? All you have to do is invoke the Nearby Messages API and say you want to subscribe to the messages associated with that. The only thing that is beacon specific here is the fact that we are indicating that we only care about messages that come from Bluetooth LE devices. Everything else is done magically by those API console projects that I just described. It already knows which beacons you're interested in because they're registered with your beacon API that's tied to the API key you're using. Okay, so the credentials govern all of those pieces. You don't have to declare specifically, these are the beacon types or these are the namespace IDs or anything like that. That's all managed in the beacon API. And as long as those credentials are set up to marry to the right proximity beacon API, then you'll just start to see that stuff come down to the device. Okay, so in this subscribe method, The one piece of information that's interesting is you pass a callback called a message listener. And the message listener is where those messages will be delivered to you as your device moves into or out of proximity with the different beacons. Okay? So you can subscribe to this, and as long as you are subscribed, beacon messages from the beacons that are near those devices are going to be pushed down to the device, and you can react to them. Okay? And I'll show you that code here in just a second. But one thing that I want to point out, unfortunately, is that nearby messages does not work in the background. You cannot attach this to a service on Android or some other API that would allow this to run while the application is backgrounded. It just doesn't work. Okay, they've explicitly disabled that because, at least for now, the way they've implemented this, using the radio to scan and connecting to the API and all that, is fairly power inefficient. So they only want you to use this when the user is actively engaging with the application that is scanning. Okay? So if you want to marry this with doing something in the background, I'll show you an example of how you can kind of do that. But you have to go outside nearby messages a little bit to make that work. Is there a question? Yes, that's just, the question was, is that the same for all beacon types? It has to do with using nearby messages, not any specific beacon. Yeah. So that is a downside. Now, I have heard that they're not happy with this, and they would like to make it better. That doesn't scream to me any recent timeline or anything like that. So I know they want to fix that, but I have no delusions about the fact that it's happening anytime soon. Okay. So if you need background scanning in your beacon application, and most of us do at some level, you have to kind of work around that a little bit, and I'll show you, I may not be able to go through all the code, but I'll show you a basic example or where to find one of how you can kind of marry the two together. Okay. All right, so then on the callback side, the message listener looks like this. It's fairly simple, right? You have two callbacks, found, lost. Messages are found when the proximity beacon moves into proximity with the device. And at some time later, if you walk away from the beacon and it recognizes that it's no longer there, you'll get a call that it's lost. Right? Fairly simple to implement. Not a whole lot going on here. These messages in both of those callbacks are the elements that contain the attachments from your beacons. So notice that the callbacks you're getting on the client side never actually see anything associated with this piece of hardware. That's all happening under the hood. I have no way of asking for the advertised ID of this beacon. That's all going on inside nearby messages. Instead, what I get is the attachments associated with that beacon, which is what my application should be designed to use to interact with whatever that real thing in the world is. Make sense? Okay, yes? No. So the question was, can you do any ranging with the API? No, you'll have to go direct into the BLE APIs to get transmit power and stuff like that for that sort of thing. Good question. Okay, now just another side note for those of you who are Android developers. These callbacks don't happen on the main thread. Don't ask me why, they just don't. Okay. So the only reason that's important is if for some reason you wanted to try and manipulate the UI from these calls based on the data coming in from the beacons, you can't do that. Right? You have to post it to the main thread using a handler or whatever other mechanism you want to use to do that. You can't touch the UI from these callbacks. These callbacks are in the background using some IPC stuff, and you have to get back on the main thread to do that sort of thing. Okay, so just a tip there. All right. So a couple things before I run into a quick demo. Other pieces of information if you want to learn more. API documentation for the Beacon API as well as nearby messages. I have done a blog series on the Proximity Beacon API that basically covers the same information that I've been talking about you here today. So if you'd like to read about it rather than listen to it, you can look through the blog series that we have on our site, newcircle.com. You can find it directly by going to the beacons tag, or if you just go to our stream, which is our blog, it's just newcircle.com/s. There's a big old banner at the top for the Proximity Beacon series and all that. Part of that series is a screencast video I did from a previous talk that describes the beacon formats themselves. So if you're more interested in how is Eddystone different from iBeacon, and how does that tie into this thing called the physical web and all these other things that we mentioned but didn't really go into, there's a video up there you can watch. It goes through some of that stuff as well. And then sample code. All my sample code for all my things that I write, you can find at milehighandroid.com. And the two examples that I'm going to walk you through here tonight are also up there as well. Okay. Questions before I go on to the demo? Yes. Sure. So the question was, are there any Apple restrictions for iBeacon? To implement one, yes. Like you said, you have to go through the rounds of NDAs to get in the iBeacon program so that you can see the format and be able to reproduce that format on a beacon that's advertising. Right? So all that's covered under being a part of that program. And yes, I can tell you from experience that if the word Android shows up anywhere in that form, they will reject you. I had to go through 3 times before they finally let me sign the NDA because Android was in the wrong place and they did not like that. On the application side, you're kind of getting around that because you don't have to deal with writing that code. Technically speaking, if you wanted to parse the iBeacon format, you'd have to know what it was. So you'd have to be able to see the spec and do all that sort of thing. But the way that they get around that is that the beacon manufacturers typically provide client-side libraries if you want to do it directly. So you're never actually seeing the format. They parsed it for you. And however they got around it, I don't care. You know, if they actually did. Same thing here. Google is parsing the beacon format for you. And you never have to pay any attention to what the iBeacon data was because that's married to the API and it's all done in the cloud service and stuff like that. So whether or not they're properly a part of the program, not my problem, right? So you don't have to worry about it because you're not parsing them directly. Good question. Yes? Sure. What's the range was the question. Depends on the device. You know, typically these things come with some ability to be tuned so that you can control what the range is for your application. So I could tune it down to where you'd have to basically be standing right in front of my face to see this beacon. What you're probably asking is what's the maximum possible range? You know, it depends a lot on environment, indoor, outdoor, that kind of thing. But typically, you can easily see a Bluetooth LE device that's advertising within the same room. Definitely on the same floor, usually in the same building. So easily indoors, a few hundred feet, you know, maybe 100 yards or so. In open air, maybe 2 to 3 times that. So it depends a little bit on conditions, but those are the rated specs. Good question. Okay. Yes? They are. Yes. Which actually brings up an interesting point that people may have thought, but nobody asked. Does this work offline? No. So an interesting point to realize is that you're relying on their cloud service to marry those advertised IDs down to the attachments. If you recognize beacons, but you have your devices in airplane mode, you're not going to see those messages, right? So this whole thing is predicated on a network connection, absolutely. There's no caching or fallback or anything like that so that it works offline, at least that I'm aware of. Did that answer your question, or was there another one in there? Oh, okay, one more. So what's Google's motivation for providing APIs, like just make the platform better, or is there other things as well? Yeah, my favorite question, why did Google do this? I have no idea. You know, why does Google do anything? I would say that the true answer probably lies somewhere between using your data for something interesting and they're using it internally for something else. I know that they built this because there were a lot of large mobile clients who were trying to do this sort of thing on Android, doing it themselves. And I think maybe they just had enough big app developers have enough clout to say, why don't you do something to help us? But what actually caused them to go down that road? Yeah, there's probably a data element in there somewhere. Officially, no, but yes, a few. There are a few clients that they're working with directly through GDEs and some other folks that are sort of trying to help them get their feet using this product, but they don't talk about that. Yes. What's the battery life range on beacons generally, and then how much do they cost? Sure. What do they cost, and what's the battery life? Again, depends entirely on the manufacturer, because based on the transmit power, which declares how far you can transmit, and you know, whatever else they build onto the board all has to do with battery life. This one that's sitting in my hand right here, this one will run on this coin cell battery for 10 years. I've seen other ones that only run for 1 year on the same, the same battery size, obviously different hardware. So it varies a lot, but easily more than a year for the average Eddystone. Interesting point, and this is in the other video if you want to go back and read it, but iBeacons are required to transmit about 10 times as more often than Eddystone. So Eddystone batteries tend to last 10 times more, 10 times longer, because they don't have to transmit so often. But that has part of it to do with it as well. How much do they cost? I mean, developer kits for most beacon manufacturers are in the $40 to $60 range, and that usually gives you 3 or 4 to play with. Some are more, some are less, but that's pretty standard. Okay, one more and then I gotta move on. I don't know of any solar powered implementations that are off the shelf. There's no reason you couldn't put one together. But I don't know of anybody doing that as a commercial product. Now, a side note to that, there is a company here in Colorado, they're in Colorado Springs, KS Technologies. They're actually the ones that made these beacons right here. They do a lot of custom engineering outside of the beacons that they sell. And they do have a beacon that is in an industrial box that they probably could retrofit pretty easily with a small solar panel. So if you're interested in that, I could give you their contact information and you might be able to talk to them about it, but it would be a custom design. Okay. Real quick before I run out of all my time, I want to show you guys a demo. Wake up, computer. Did I lose it? There it is. Okay. So quick, Mile High Android, that's where you can see all my sample code. I won't have time to go through the actual code, but this nearby beacons and this proximity manager, those are the two applications I'm going to show you right now. Okay, so you can go here, you can look at the code, you can see how they work. They're pretty straightforward. All you have to do to get them up and running is create your own dev console project with the Beacon API and nearby messages. Okay, so as I mentioned before, if you've never seen the developer console before, this is what it looks like. But you sign into this console, console.developers.google.com, create a new project, and one of the blog posts that I have in that series can walk you through creating a new project if you've never done that before. Go into that project, and the two APIs you need to enable are proximity beacon and nearby messages. Okay, just flip those switches, and you're pretty much ready to go. So I mentioned that both of those have to be enabled on the same project. The only other thing you need is a pair of credentials. And you'll need 2 credentials, an OAuth client ID, which is what you will use for to interact with the Beacon API directly. So whatever your management console is to provision and register and all that stuff, you'll need a client ID for that. My client ID is set up for Android because my manager application is running on an Android device. If you had this as a web backend or something like that, you would create one of these that's web credentials. So there's different types for different platforms. And an API key. The API key will be used alongside nearby messages. So the device application itself will have this API key burned into it so that nearby messages knows which project to communicate with. Okay? So 2 credentials, 2 APIs, that's all you need. With that, you can use the sample code that I've got on those 2 projects right out of the box. Okay? Well, that and some beacons. You'll need to have some of those. Okay. So let me see if I can get this running real quick. Those of you who are Android developers, if you don't know Visor, you need to learn it. It's amazing. Great way to get your device shown on the screen. Okay. So I've got 2 applications that I want to walk you through just real briefly. The first is I'll do the Proximity Beacon Manager first. This is the application that communicates with the API to register new beacons, create attachments, all that stuff. Okay. And then I'll show you the implementation that uses nearby messages to scan for those beacons and return the values. Okay. So we'll do the Beacon Manager first. Now, the first thing that this asks me to do is log in with a Google account. And I'm just using Google Play Services APIs to authenticate my Google account and do all that stuff. So the code in there to do that is very simple, and you'll see it in the sample. All I have to do is pick a Google account that's set up on my device, and it will authenticate. Now, again, the code to do that is 10 lines maybe. There's not a whole lot there because Play Services sort of handles all that for you. The account you use must be an account that's attached to that console project. And it must also be an admin on that project. Okay? Otherwise, you won't be able to access all the API methods. So the account you log in with is on the same project that has those credentials I just showed you. Now, what this first application or the first screen is showing me, this is just asking the beacon API to list all the beacons I have registered. So previously, before I ever got here, I registered 3 of my beacons that are sitting around this room. This is not telling me that those are the beacons I can see. This is just a request from the API saying, here are the ones you've registered. And they each have a name, a description, and actually if I rotate it this way, you can see a little bit better. A name, a description, and their current status, which happens to be they're all active. Right? Each beacon can have attachments associated with it. So if I tap on one of the beacons, it will bring up all the attachments I've created that are associated with that beacon. Okay, so there's another API method that says for whatever beacon name, get me the list of attachments. These attachments that are in here, I've basically just implemented a very simple JSON structure that I'm going to use on the client side to read the data. These are emulating offers that are like coupon codes that you would put around a retail store. Right? So each of these beacons has 2 pieces of data in a JSON blob, which is the department of the store and what the offer is. Right? This is just data. I could make it anything I want. I just chose JSON because it's easy to read and all that stuff. Okay? You can have more than one attachment on a beacon. So for instance, this top beacon has 2 attachments associated with it. Okay? And that will become important when you see the client side later on. So I actually have 4 attachments across my 3 different beacons. And this is all stuff that I created beforehand just using the API calls. So if you look at the sample code for Proximity Manager, that will show you how to interact with the Proximity API directly. So we're talking REST API methods just using regular network calls. Okay. One of the nice things about this, or rather about putting this on a mobile device, is I can also build in a scanner. So if you were to have your provisioning application on the web backend somewhere, when you wanted to register a new beacon, you'd have to figure out what that beacon's ID is, come up with a way to manually enter it, make sure you didn't typo it or something like that. My provisioning application is on an Android device. So I've created an activity that just scans for active beacons. And when it finds them, it uses the Proximity Beacon API to determine whether or not they're already active. Okay? So each of these that are in this list are the 5 beacons that I have around the room. And you can see the 3 of them that are already registered from the previous screen that I showed you. So the 3 beacons that I have registered in my API console project, registered to me, are showing up that way. And I can tell that they're mine by asking the API to give me the data for each beacon. So what's actually going on here is it's scanning for Bluetooth to get the individual IDs, and then it's asking the API, can I have the metadata for that beacon? One of 3 things is going to happen when I do that. It's either going to say, sure, here you go, here's all the data, which means 1, it's already been registered, and 2, it's been registered to me. If I get a 404 back from the API, that tells me that that beacon hasn't been registered yet. And those are the ones that I'm showing up there in green. Those are beacons that are active, but they don't have a home in the beacon API yet. So I could safely try to register that as a new beacon to me. Okay? The third thing that might happen that I don't have on the screen right now is you could scan for a beacon that you don't own but has been registered already. That would return a 403 from the API, meaning there's forbidden access. Okay? So I'll either get a 404, a 403, or a 200. And one of those 3 things tells me whether it's my beacon, your beacon, or nobody has it yet. Okay? So we're using those to determine how to implement the view here. And then I won't go through the process, but if I tapped on one of these beacons that was able to be registered, a dialog would pop up. I could add some additional description information, and it would register it with the API. Okay? So all the basics, it's not super pretty or well designed, but all the basics of a provisioning application are in this demo. Okay, so it would at least be able to get you up and running to create a few beacons, add some attachments, and see what happens. Right? Okay. So as I mentioned, I've got 2 beacons that are advertising, but I don't have them registered. I have 3 beacons that are registered in the room, and each of those has a total of 4 attachments. They each have 1, and one of them has 2. Okay. So if I go into this nearby beacons application, you won't see the permissions dialog because I've already run it once and I already went through that process. But the interesting thing that happens is in this application, the foreground activity is subscribing to nearby messages and reacting to each message that comes in. Notice what's coming in. It's those attachment values that I showed you before. We're just displaying the department name as the list view. And then if I click on the item, it'll display what the other text was. Right? So fairly simple application. But notice there's 4 elements there, even though I only have 3 beacons. Because each one of those attachments comes in as an individual message. Okay. Now I mentioned that you're only supposed to do this in the foreground. Interesting thing that I actually just noticed this morning because it wasn't in a previous version of Play Services. When nearby is active, Play Services actually puts a notification in the top telling the user that you are using nearby API right now. You are actively subscribed, which means you're doing stuff that potentially is draining their battery. Okay? And they actually give them controls to shut you down from in here. So something to be aware of. The sample doesn't really handle that very well just yet, but it's just important that this is a foreground only thing. Right? You're not going to have that running when the user leaves the activity and everything goes into the background. Now, again, I don't have time to show you the code, but there is a checkbox in here that if I enable this, will set off a separate service that uses the Bluetooth LE APIs directly to do a background scan. Okay? So if you're interested in how would I use nearby but still do something in the background, the nearby beacon sample has a service that does background scanning in a safe background way and still uses nearby API when the application comes to the foreground. Okay, so you can see those 2 things kind of in concert, maybe get a good idea of how you would want to do that so that I can still generate a notification when the user is walking by the beacon in the application or the phone's in their pocket. But once they actually take their phone out and want to engage with that content, I can use nearby to get that richer attachment information down from the API. Yes, question? Which, ask that question again, I'm sorry. Yes, that's a very good question. So the question was about permissions associated with scanning. And there was a change in Android 6.0 or Marshmallow where Bluetooth scanning requires the location permission. Didn't used to, but it does now. The sample accounts for that. So if you look at the sample, you'll see where it's checking to see if we have the location permission. And on Marshmallow devices, if we don't, it's going to pop the dialog. So that flow is integrated into the sample because it is required. If you don't do that, you won't be able to scan for anything. Depends on your application. This one does it on launch, but you know it would probably be more integrated with a specific feature where you might want to do it. It depends on how your application's written. Okay. Other questions on that? No? All right, well, let me do this. I will pop, well, I'll quickly remind you that, again, you can find that sample code by just going to Mile High Android and clicking on those links. Those will take you to my GitHub pages for those projects. You can clone them. The instructions for where to put API keys and stuff like that, if you want to play with them, is in there. And you can kind of mess around with that stuff and look at the code. If you look at the code, you have any questions for me, please feel free to contact me at any time. I'll go back to the beginning here and put up this slide, which has my Twitter information, Google Plus information. I can give you my email if you want to contact me. I love questions. So that's all I've got for you guys. Thank you for your time. Appreciate it.